Okay guys, in this video we look into the Kepler's second law. Before this we will look towards the Kepler's first law. Okay, Kepler's first law, what is stated by Kepler's first law, it just tell us about the shape of the orbit, which is in elliptical orbit. Okay, that is the shape of the orbit of planets which revolving around the sun, and sun is at the one of the focus for the ellipse. Remember, ellipse has two focus point, okay, two foci. So one of the focus should be our the sun, and the orbit is in shape of ellipse. That is Kepler's first law. So for this session we look into Kepler's second law. Okay, Kepler's second law of planetary motion. Okay, that is the full name, Kepler's second law of planetary motion. Okay, what is stated by Kepler's second law of planetary motion? From what you have in your textbook here, okay. So a line that connects a planet to the sun sweeps out equal areas in equal times. Okay, a line that connects a planet of the sun sweeps out equal areas in equal times. Okay, you have a simple diagram shown in your textbook there. Okay, observe figure 3.26. If a planet takes the same amount of time to move from A to B, so it is A and B. Okay, I just redraw the diagram here. Let's say this is our sun. Okay, this is our sun. It is one of the center. Remember, one of the center, and this is imaginary center. And then let's draw an ellipse. Okay, let's draw an ellipse. Okay, this is one beautiful ellipse. Okay, so what is stated by Kepler's second law? A line that connects a planet to the sun sweeps out equal areas in equal times. Okay, let's say we have an object orbiting the sun, or a planet orbiting the sun, and then it sweeps, meaning that it will move from this point A to B. Okay, it sweeps from A to B. Okay, and then it will produce the area. Okay, it will produce an area. So this is the radius or the distance. So this is the area that being swept by the object when it moved from A to B. Okay, so this area should be equals to any other area if the time, okay, if the time here for this planet to move from A to B, let's say A to B, it takes 2 months. Okay, let's say it is 2 months. 2 months. Okay, so if we investigate other position from C to D, okay, C to D, this is the distance from the sun, okay, C to D, and let's say the time taken from C to D is also 2 months. Okay, 2 months. So the area here that being swept by this planet from C to D is equals to this area of yellow one. Okay, this law also known as law of areas. Of course, you can prove this if you know additional information about circular motion. Okay, it is easy to prove that by using circular motion. Okay, let's take another point. Okay, another point. Let's say the area that being swept by this planet when it moved from E to F. Okay, E to F. Okay, let's say the area here, okay, area, okay, this red area is equals to this area, okay, the blue area. So what can be conclude there? Okay, what can we conclude from this situation? Okay, we can say that since this area that being swept by this planet when it is moved from E to F is equals to the area when it moved from C to D, so that's mean we can conclude that the time taken, okay, the time taken, okay, the time taken here for this object to move from E to F is equivalent to 2 months. So how can we see that? We can say that based on the law of area. Since the area is equals to this area, okay, the red one here equals to the blue one here. So that means the time taken from E to F is equals to C to D. Okay, so that is stated by Kepler's second law of planetary motion. Okay, if you look into your textbook here, okay, textbook here, so we have B here. If a planet, okay, if a planet takes same amount of time to move from A to B, okay, A to B, from A to B, and from C to D, C to D, okay, so the time taken, same amount of time, okay, same time from A to B, C to D. So what can be conclude? We can conclude that the area of AFB, okay, this area, okay, this portion of area is the same as the area of CFD. Okay, CFD. Distance AB is longer than distance AD. Of course, this is the nearest distance. We can say that it is in the perihelion region. Okay, so the distance is near to the sun. This means the planet is moving at higher speed from A to B. Okay, so another things that we can say from Kepler's second law. Okay, A to B 2 months, C D 2 months. Okay, we can look that the this distance. Okay, this distance. Okay, this distance. Okay, this distance. So A to B is larger than C to D, but the time taken is equals. So what can we say that if the object can move from A to B, where A to B is at a larger distance at the same amount of time, so that's mean when it move from A to B, it require a larger speed. So V at AB, okay, V, the speed at AB, of course, will be larger than the speed at CD. Okay, so CD only small distance, but it require the same amount of time. So that's mean when it is here, it will move at a slower speed. Okay, so slower speed. So that is all about of the Kepler's second law. Of course, we will discuss about this later in our live session. Okay, so that's all, and thank you.